Unit 7, Lesson 9, Density. I can tell you that the density formula is equal to the mass divided by volume. So please recall this formula when needed. Recall the following conversions from algebra in your science classes. So 1 meter is equal to how many centimeters? You're going to have to look at your reference sheet in order to determine what that could be. So 1 meter is equal to 100 centimeters, and 1 kilogram is equal to 1,000 grams. The conversions for pounds to ounces and pounds to tons is on your reference sheet, which is given to you in the back of your Regents exam, so please keep that in mind. You're going to need to know them in order to convert these following units. So the way in which you're going to do that is set up ratios, making a proportion so that you can cross multiply and solve for the unknown value. So we want to convert 5 centimeters to meters. So I know that 1 meter is equal to 100 centimeters. That's on the reference sheet. And I'm given 5 centimeters, and I need to find out how many meters. So all I need to do is cross multiply these two values, and I get x is equal to 0.05. So for the second one, I want to go from meters to centimeters. I know from the reference sheet that 1 meter is equal to 100 centimeters. I have 3.2 meters, and I'm looking for centimeters. Okay, so in order to get x by itself, all I have to do is cross multiply these two and divide by this one, and I end up with 320 centimeters. For number 3, I have 50.7 kilograms, and I need to find out how much that is in grams. So what I do know at this point, or from the reference sheet, is 1 kilogram is equal to 1,000 grams. I'm also given 50.7 kilograms, so I'll write that above this kilograms. And I'm looking for x grams. So all I have to do is multiply these two together and divide by 1, and I get my value in terms of grams, which is 50,700. And for the last one, I'm given grams. I need to convert to kilograms. So again, 1 kilogram is equal to 1,000 grams. I'm given 3721 grams, and I'm looking for how many kilograms. So all I have to do is cross multiply here and divide by 1,000, and I get 0.0372 kilograms. So the reason as to why we have to do this is because we need to refresh your memory, because in terms of units, you may need to convert. So when reading these types of problems, anything regarding solids, whether it's density, whether it's volume, whether it's area, please make sure that the units are cohesive, that they're all in terms of the same unit. If not, you're going to have to do conversions just like what we did here. Here's the density formula again. So what does density really mean? You're going to go ahead and watch this video. What I suggest that you do is record all the notes for this video and then go back and replay the video so that you can get this web address again. Copy and paste it and see it. Example 1. A square metal plate has a density of 10.2 grams per cubic centimeters and weighs 2.19 kilograms. So here's the change right here. There you go. We have grams and we have kilograms. So we know that this is equal to 2193 grams when you do the when you set up the proportion and you do the conversion. So we want to calculate the volume of the plate. So density is equal to mass divided by volume. And we know that the density is 10.2, and that's equal to the mass of 2193 divided by V, which is what we're solving for. So in order to solve this value for V, all I have to do is switch these two, very similar to trigonometry. And we get this to be 215 cubic centimeters. If the base of this plate has an area of 25 square centimeters, determine its thickness. So let's let H equal thickness. And we know that volume is equal to capital B times H, where B is the area of the base. We know that the volume is 215, and we know the area of the base is 25. And what we're looking for is thickness, H. So divide out the 25. We get H is equal to 8.6. So the thickness of the plate is 8.6 centimeters. A contractor needs to purchase 500 bricks. The dimensions of each brick are 5.1 centimeters by 10.2 centimeters by 20.3 centimeters. And the density of each brick is 1,920 kilograms per cubic meter. If the maximum capacity of the contractor's trailer is 900 kilograms, can the trailer hold the weight of the 500 bricks? Justify your answer. Okay, the first thing that I would do is find the volume of an individual brick. So 5.1 times 10.2 times 20.3 gives us 1,056. And then we need to take that and multiply it by 500 bricks. And that gives us a total volume of 528,003. We know that the density is equal to 1,920 times 500, 960,000 kilograms per cubic meters. And for the volume, I forgot to write down, is cubic centimeters. And this is in terms of meters. So we're going to have to do a conversion to check to see if the maximum capacity of the contractor's trailer, that is 900 kilograms, can hold the 500 bricks. So I need to convert centimeters to meters. In order to save time at this point in time, I'm going to have to hold it off here. I will come back to this and I will definitely refer to you on this. Due to time constraints that you're unaware of at this time, I have to move on to the next one so that I can get to making the video for the next lesson so that you're prepared. Example 3. Trees that are cut down and stripped of their branches for timber are approximately cylindrical. A timber company specialized in a certain type of tree that has a typical diameter of 50 centimeters and a typical height of about 10 meters. The density of the wood is 380 kilograms per cubic meter, and the wood can be sold by mass at a rate of $4.75 per kilogram. Determine and state the minimum number of whole trees that must be sold to raise at least $50,000. So we know that density is equal to mass divided by volume. And here's my cylinder tray. I have a radius of 25 and a height of 10. The reason as to why I have a radius of 25, because the given diameter is 50 and half the diameter is equal to the radius. A lot of kids forget that, so please make sure you're reading and you're concluding that. Height is 10, I've adjusted for. The density is 380, so let's fill that in. So we know the volume formula is equal to capital B times H, where B is the area of the base. The base is a circle, so the area of the base is 5 squared times pi times 10. So 25 times 10 is 250 pi. If we cross multiply these, we are going to get the mass, which is also the weight. And that is 19,625. Then we're going to multiply it to the rate of $4.75. And we get $93,218.75. I'm not going to continue this problem as well. I don't think that this is a good representation of the questions you'll be asked with regard to density. They're not straightforward, and if you continue and do the homework at this time, you will end up with more straightforward questions. So go ahead and do that at this time. I'm not going to finish this problem, and I'll talk to you about it when I see you in class.